Everyone able to hear me?
Yes, sir.
Malay?
Yes, sir.
Okay. Myself, Dr. Vijaynath. Today was my lectures are digital system design with Verilog. Now we introduce one fellow members. He is the CEO of Ignytion IO, with the company of uh, chip design, and they are also going to step out by the Belgium and Europe countries. Okay, so he have a good spot on that domains. Now, in the place of mine, I am giving the opportunity to Rishabh Kumar and his team for demonstration of the what they are doing and how the student can get the job and what is the opportunity of further work with their company. Okay, and what the computer science people saying, sir, what is my role in this your chip design? You know, this artificial this AI is come up over there. Before we have used the without AI driven tools, but right now we are using the EDA tools that is driven by AI, artificial intelligence. Okay, so what they have studied, you can do it better over there. So several things we can control by the softwares. Okay, and with that softwares we can create and design the perfect hardware. Okay, so for that purpose your requirement is there, your knowledge should be there. That's why we are only one particular subject. We have versatile subject over there by which we can send our teams to in different directions, and everyone should be aware that what is going on. At least you should be aware what is the use of that. My lectures I will introduce to Rishabh Kumar, this CEO from Ignition IO. Okay, so he will be deliver lectures today and we will be demonstrate our parts later. So now I request Rishabh, please
Yes, sir.
start this year.
Yes, sir. Thank you. Thanks a lot, sir, for giving this opportunity to come into this and to talk about the things that we are building. And completely, I agree with the fact that semiconductor and the chip is the new era. It's a new trend which is happening in the tech. And we, coming from the tech industry, we are seeing this across the globe. That this is the right time to put our effort and energy into the semiconductor and chip design. And irrespective of any branch, whether you are mechanical, very rightly said, sir, and it's very enlightening for me also to tell people that anyone can design the chip, whether you are from any branch, because ultimately that's the backbone of the technology. Yeah. So I will share my screen quickly, and I will introduce myself and I colleague Soumyajit. We two will be giving you a brief idea about the things that we are building and the overall semiconductor, a big picture. So let me share my screen. So I hope my screen is visible.
Yes, Rishabh, I can see this thing.
Okay, great. So first hide this. Okay, so as sir introduced, our company name is Ignytion IO. We are an Indian-based company, and today we are going to talk about the IGNY CLI on Crucible, which is a developer platform with open source silicon design, and also we will talk about a little bit on the pre-RTL flow with virtual prototypes. The whole idea is to make chip design more accessible, programmable, and reproducible. Yeah. So agenda for today, we will be giving a brief introduction. Then we'll talk about the overview, then the pain points that we are targeting to solve, the solutions. Then we'll give a short demo of the platform. Then my colleague Soumyajit, he will explain about the virtual prototypes and other interactions. Yeah, and then we'll open the doors. So today I am myself, Rishabh. I am the product and software architect for this product, and also basically heading the whole engineering initiative in the company. And I'm joining with Soumyajit, who is the senior engineer. He is experienced into system engineering, software engineering. He himself has been a silicon engineer, and he has traveled across the globe. He has seen the foundries in Europe, and he comes with a very rich experience into chip design. And he would be able to give a better ideas on many other technical deep dives. Yeah? So what exactly we are trying to do? So we are trying to democratize the end-to-end silicon development. So anyone and everyone should be able to design the chip. So democratizing means access to everyone, opening the platform so that everyone should have the access of this technology of chip design, which is one of the key pillars of our country and for the global technological prosperity. Just to give a brief idea on how this whole semiconductor industry works. So you can see on the top, we have the fabless model of the semiconductors. And on the bottom, you can see there is an integrated model. So let us briefly understand the fabless model. So the fabless model, you can see the chip is designed by the fabless companies. Let's say NVIDIA, one of the big tech company, then Apple, then AMD, and many other companies you are seeing on the top left side, which is the fabless chip designers. And they are the new big companies of the globe, right? NVIDIA is the topmost company, and it is up because of the chip. And then basically they design the chip and then they outsource the fabrication. That means that they give it to someone else, to some other companies to fabricate the chip. So those companies are called foundries. So you can see there is a TSMC, right, on that, and which is a Taiwan-based company which fabricates the chip, and then the testing and packaging happens, which we call the OSAT, right? So this is one model, and then integrated model, the IDM, in which the entire design, fabrication, testing, everything happens in one company. For example, Intel, Infineon, so these are the integrated model. And on the middle, you can see there is a supplier layer. So we have different tools that are coming, which are used for the chip industry. So we have the manufacturing equipments. For example, Lam Research, you can see on the middle. Then there is ASML, which is one of the biggest Netherlands-based company. And then there are raw materials provider. Then, on the left-hand side, you can see there is a design software, R&D tools, and IP. Now, this is the place where we operate in. This is our company. We are in this category. But overall, you can see that how big the semiconductor value chain is and how big the opportunity the semiconductor industry is bringing across the globe and in India. Yeah. So what is the inflection point for the open silicon infrastructures? The first point is AI hardware demand, right? So you're seeing there are lots of Gen AI tools coming in every day. You hear about Chat GPT, you hear about Claude, you hear about Gemini, and many other things. But ultimately, the basic reason that these chips and this AI that you are able to see is because of the hardwares, right? The chip that runs the GPU and the TPUs, those things. Then on the right-hand side, you can also see there is a semiconductor sovereignty, right? So currently, the semiconductor is being controlled by some of the foreign players, US and Europe, and then Taiwan and many other places. So now this is just not a matter of technology, but it is also a matter of sovereignty for us, so that we control our technology at our home. So that's the reason many countries are trying to build these ecosystems, and India is one of the pioneer, one of the, I would say, in the race, right, to accelerate our semiconductor startups. And then you can see there is a hardware startup growth. Lots of new companies who design the chip, who design the hardware, are emerging on a daily basis. On a daily basis, the new companies across the globe, and especially in India, in Bangalore, Hyderabad, many places, these companies are emerging. And then there is a concept of open PDK emergence. So PDK means process design kit. That means this is one of the kit which connects the design to the foundry, right? So using the PDK, you can check the right design rules and you will be able to fabricate your own chip, right? So it's not now difficult to design a chip. You can just use the open PDK, for example, Global Foundries or Skywater, and you will be able to even, maybe if you are very good and then you get a good skills, maybe you can design one day a chip that will be delivered at your doorstep, and you will be able to design lots of things around it, lots of machines around it. So that's what the engineering excellence that this inflection point or the chip design brings in, right? Now, the idea is that the component exists, but the orchestration layer does not, and that's what we are targeting. We are trying to build an orchestration layer which orchestrates the whole chip design systems. Yeah. Now, what is the pain point? So all of you would have noticed this, that software is very much easily accessible, right? I mean, it runs on open programmable platforms, iterations is fast, continuous, and developer driven. Anyone can do the software development. If anyone is interested to express their pain points or express their engineering skills and excellence and build something, they can just go to website and they can learn how to build a web application. They can learn how to build a mobile application, and then they can do the software development. But the silicon is something which was not possible till now, because it was still fragmented, it was tool heavy, and there was lots of problems. And that's the pain point that we are trying to solve. We are trying to basically build a platform which make silicon also as accessible as democratized as a software is. So what exactly from software developer platform to the need for a software platform in silicon. So you can see on the left hand side, the software evolution history is there. So in the beginning, there was a Turbo C, and maybe many of you in your beginning days, in your school days, or you would have compiled some code on Turbo C, you have written a C++. But that was a little bit older era, 90s and 80s maybe. Then the modern ID came in, right? You can see there is integrated environments, VS Code, many Git workflows, many things came in, right? And now today, we are sitting on an AI native development era. So you have co-pilots, you have agentic workflows, you have Cloud Code, and many other tools are there in which you can do the software development. But silicon has been still fragmented. We understand that because of course, the barriers was very high. The tooling complexity was too much, and there are the closed systems. The ecosystem was also closed, and the reason was because it was not very open. It was not open source. It was not open for the silicon designers. So this is the pain point. And what we understand is that it's a fragmented. The tools, silicon design today has been facing a high friction ecosystem, which was like fragmented open source chaos. 75% of the engineers, what we met and we talked, they said like, yes, it is too heavy. And of course, there is an institutional barrier. It's not easily accessible as software. And that's the pain point that we have identified. So basically, the idea is that software has a plethora of modern developer tools. For example, it is easily available and accessible. You can just download and use it. There is no institutional barrier, and it's a real democratization that has happened in the software. So we have Codex, if you guys have used it. Currently in software development, it's very getting popularity. Then we have Cloud Code, then we have Cursors, then we have AI Studio. And using these tools, you can do a very good software development, and then that will be something that is possible. Now, in the modern semiconductor development, that also requires something new. It requires a new paradigm shift, which means that we have to make the system more open, more programmable, more developer-driven. Yeah. So shifting from a manual to a non-standardized flows to programmatic automation and reproducible environment. So that means the easiness of software development should also we are trying to bring in the silicon development. So anyone and everyone who has the interest in engineering and who aspires to excel in engineering, they should have the access to the chip design and this knowledge. Yeah. So silicon now will have a modern developer tool, which will be more easily available and accessible, which will be download to use. There will be no institutional barrier, and it's a truly democratized tool, which we call our first offering, which is IGNY CLI. So it's a CLI command line interface, but ultimately, of course, CLI is the beginning of any product, any applications. Over the top, we write the UI, we write the AI, many things, but this is the core of our product. And this is what gives you the idea that how the chip design can be achieved using the IGNY. IGNY, as in Hindi, we call it also Agni. So this is the fire that we want to bring, and we want to democratize the chip design till everyone. Yeah. So what exactly Ignytion IO, so or this particular tool can give you? So as you can see on the left-hand side, there is a fragmentation of the tools happening. Lots of open EDA and open PDKs and open IPs are available, but they are fragmented. There is high barriers. And our orchestration layer streamlines it. So you can see we first do the curated distributions of design suites, reproducible environments. Then we have a Python inbuilt in it. And of course, our tool is also GenAI assisted. So I will give a quick demo on the thing that I'm just now explaining, the environments and the Python and all those things, so that you will get a brief idea. This is the POC that we have created, and soon it will be available to many. Yeah. So I hope my screen is visible. Yeah. Okay.
Yes, Rishabh.
Yes, yes, visual.
Okay, perfect. So you can see this is what the basic tool nowadays, any software tool looks like this, right? So I have already asked something to the GenAI, and GenAI was able to give me an answer that, how to quick start and, all those things. What is the mental model? It is automatically generated. I have not generated these graphs that you are seeing here, right? The GenAI is smart enough to generate it and tell that how to operate the tools. So you can see how cool it is, right? And how wonderful it is. So what you have to do is you have to just open your agentic place. So here we have created our agents, or we are not basically not agents, but yeah, we are using the Cursors agents, and it just works on the context that we build on. So you have to just any software development or any engineering chip design also, it can be AI assisted. So maybe to begin with, You can ask anything to the agent, but yeah, I will give you a heuristic way first. So what you have to do is you have to just type igni and init. So as soon as you type igni init, you can see we are directly into the environment, right? So you are into the environment, you are ready to basically design your chip, and first, you can do a more software version of softwareization of your design, right? So how to know? You have to just do igni help, and this gives you, what are the different commands that you can run. So igni init, igni list, igni run. So good detailed explanations are there, and then you can just say igni, let's say list. So for example, this gives you a lot of amount of tools and their explanations that why and where they will be used for, right? So for example, you have YOSYS, it's a synthesis tool. Then you have Renode, which is a virtual prototype framework. And I think you will get to know more once you study and understand the whole ecosystems. But yeah, the kind of ecosystem is really good. Or you can ask the agent also, like, hey, please uh, give me the quick starter for Igni. So it will just plan the next moves. It will read, see you can how it is working, right? And it gives the full idea. Yeah, you can ask many things. You can just chat to it and understand more, right? So for example, let's start with the the starter one. So Igni env create. So this is the environment that we will create. Yeah. So let's say I'm creating Igni env. First, I will do Igni env list. It will tell me how many environments are there. Let me create a Igni env create. I will create, let's say, validation. Yeah, one of the environment. So environment validation is created. Then I will create my own workspace because it tells me to do that. This is one of the path. Yeah, workspace create hyphen path, and then I will just do. Let's say I want to design M33. Yeah, that is, or let's say chip for power electronics. Right. This is one of the thing. Let's say PE. I'm just naming it just for demo purpose. It's all your creativity and your thing. Yeah. And then I will just say validation because this is the environment that I created. Yeah. And oh, sorry, I think I did some new workspace. Oh, sorry, hyphen.
Add double hyphen there. Yeah.
Yeah. That's right. Sorry. Yeah. So the thing is that I'm more into business and developments, but yeah, the right technical guy will be speaking after me. Yeah. Okay. So you can see we got our power electronics device, basically the project workspace created. Yeah. And now you can just go into your workspace, which is chip for, oh, sorry, CD chip for PE. Yeah. So we are into the chip, the project that we created. And after that, we can install the tools, right? So let's say GTK Wave. Yeah. So GTK Wave is one of the very popular tool, which is used for plotting of the graph, plotting of the results, simulation results, and anything. Yeah. So I'll just do Igni tool install GTK Wave. Yeah. And yeah, once this is done, then I can just say Igni run tool GTK Wave. Sorry, Igni run tool GTK Wave. I hope it should work. See, so we have the GTK Wave created. Now, of course, this is just the tool installation that I talked about, but once you have the data and everything created, you can very easily plot your graph, see it, and work with it. Similarly, you can also do, let's say, synthesis, right? So Igni tool install. Let me see if YOSYS is up. Okay, so we got the YOSYS installed. Now we can say Igni run tool YOSYS. Yeah. So we are in the YOSYS. See the synthesis. So you can see like every tools which is there in the available in the chip design, which is open, can be accessible just like any software. And now you can use these tools and you can start working. Now our idea is to extend it more. We want to complete the whole ecosystem, and then we are still building it. But yeah, a good place to begin and to engage with people to do the chip design just like a software. Yeah. So this is what the quick demo. Now I will just continue my slide once again. So I gave the demo, and now I will briefly touch on the design lifecycle continuity, a kind of how the whole chip design overall big picture, and then Soumya will be taking you to one of the very critical aspects of the chip design. Yeah. Okay, so one of the things that we have to understand from our exploration today, we are trying to discuss pre-RTL, right? So what exactly is a pre-RTL? Before that, let's try to understand a high level, top level understanding that how the chip translates to from the idea to the real, tangible hardware, right? So everything starts with an idea, right? In idea phase, you think of building something. For example, in software, you think of solving a delivery problem. For that, you build a Blinkit kind of an application. For mobile video recording, something like that, right? Similarly, for a chip also, you can think of anything. There is a possibility of that. You can think of creating a control device or a remote or a robot or anything, right? So that is the idea that comes in your mind, and then you start working on it, right? You do hardware, software partitioning, and many other things are there. Today we will not go very much deep, but yeah. And then once your idea is done, you have done a good engineering, you have done a good market, and many things are there. Then there is a milestone of RTL, right? So RTL is the tangible fact, which or the Verilog code, which can then be which then translates into the GDS, like physical design. Many steps are there, but RTL is one of the milestone. And then RTL, it goes into the GDS. The GDS is something that is a fabricatable information that you give it to the foundries, and foundries just print the circuits and give it to you, right? So today we will be, as we are starting this very early, so we will start with a pre-RTL phase, so that you have the end-to-end understanding, and naturally, as we progress further, we will be going into that as well. But today the focus is on the pre-RTL flow. Yeah, very quickly. So this is the one of the again a granular approach, like how magnifying. We can see these are the different stages. We start with the concept stage. You can see like architecture explorations, performance analysis. So C++ is used in this. System C modeling is used, and then we are into RTL design, then verification, then synthesis, the uses that I talked about, right? That's one of the synthesis tools. Then physical designs, and finally we do the sign off, right? And today we are talking about the very first stage in the earlier stage, which is the concept stage. Why we are talking about it? Because we are internally running this on our platform. We are experimenting system engineering, and we are even piloting with one of the commercial OEM project. Yeah.